So we've got the function f of x equals x plus 2. So it starts at 2 on the y-axis, and then it has a slope of 1. So this is a rough sketch of the graph. And we're considering between -1 and 0. So we're only considering this region right here, this little triangle. Okay. So we're supposed to find the surface area when we revolve that triangular region around the x-axis. So if we're making a revolution where the distance from the x-axis to this far point, it stays constant, it's going to make a circle for a base. So that's why we're seeing pi involved in these formulas. And then our textbook derives these formulas too. But luckily, if we're just trying to find the surface area, if we don't have to derive them, the process is pretty simple. We're integrating between -1 and 0 because those are our limits of integration. And then it's 2 times pi times our f of x, which is x plus 2. Then times the square root of 1 plus the derivative of f of x. So if you take a derivative with respect to x here, it should be just 1. F prime of x is 1. Because the 1 comes down and multiplies, the power gets reduced to 0. So x to the 0 is just 1. So these problems are chosen for our course to keep calculation simple. Surface area problems can quickly become uncalculable with standard calculus techniques. Okay, so we got 1 plus 1 squared, that makes square root of 2. And so what we'll want to do is we'll want to take this, this, and this and factor it out. 2 square roots of 2 pi. And just focus on these terms. And then we just need to find the antiderivative of both terms. So this is x squared over 2 plus 2x. Limits of integration from 0 to -1. So that's 2 square roots of 2 pi. So if I was to plug in 0, I'd get 0. And we need to subtract that by the lower limit of integration. So if I plug in -1, I get 1/2 minus 2. So that's -1.5, I believe. Let me just double check myself, because that's positive 1/2. That's -2, so 1/2 subtract 2 is -1.5. Yeah, so minus a -1.5. Okay. And so that's going to be a positive 1.5, so in other words, positive 3/2 inside here. So 3/2 times that 2, that's just going to be 3 square roots of 2 pi. So that is the surface area of the surface generated by revolving the graph around the x-axis. So here's another one. Find the surface area revolved around. Okay, so same thing. Whoops, let's zoom in a bit. There we go. So for the formula needs the derivative. So if I take a derivative, that's -3 comes down, so that's -x to the second over 2 for the derivative. Sorry, that's f prime. So when we find the surface area, we integrate from -3 to 0. And then it's 2 pi times x to the third over 6. Because that's our f of x, just going by the formula. 1 plus the derivative squared. So we're going to square this derivative. That'll make it positive x to the fourth over 4. Okay. So a refresher on integration techniques. We can use u substitution to change the variable of integration. I'm going to let the entire inside be 1 plus x to the fourth over 4. That means du is going to be x to the third, right? Because the 4 comes down and multiplies. So we have this as u, and then we can make this be du. That means all variables of x have been replaced, and we're able to do an integration in terms of another variable. The limits of integration would technically change, so you need to plug in -3 in for x into this equation, plug in 0 in for x to find out the new limits. Actually, that's not too bad. We could do that. Or you could just wait and resubstitute u equals 1 plus x to the fourth over 4 to put it back in terms of x. Either way. I will... Here, first, let's make this simpler. 2 times something over 6, that's something over 3. So I'm going to factor out the pi and the 1/3 constant. And then if we plug in -3 in for u, what's that going to be when we solve? So -3 subtracted by 1 is -4. -4 times 4 is -16. Oh, you can't find that. Okay, so here, if we plug in -3 for Oh, no, sorry, I'm doing that backwards. We need to find out what u is. So I should be plugging in -3 for x. So 3 to the 4th power. So, man, it's just going to be yucky. Because that's going to be 81 over 4 plus 1. You could change this by plugging in -3, plugging in 0, and finding out what the corresponding u value is, but I think my first suggestion is going to be simpler. Let's put the limits of integration back in once we've found our antiderivative. So I factored out those constants. This is du, this is u, so what I have is the square root of u du here, because this is u, right? So I know how to find the antiderivative of u to the 1/2 power. That's u to the 3/2, because the power goes up by 1 when you find the antiderivative. But then you need to multiply by the reciprocal of the power. That way, if you were to take a derivative, it would come back down and cancel out, and leave us with what we started with. And now limits of integration need to go back in here. But that was the whole point of avoiding it. Now we'll put it back in terms of x. And while we're here, this is 2 pi over 9 now. And then that's u to the 3/2, so I'm going to put 1 plus x to the 4th over 4 to the 3/2. And now I can resubstitute those same limits of integration because I'm back in terms of x. Oops. So if I plug in 0 in for x, I'm going to get out 1. And then if I plug in -3 in for x, 1, 2, 3, 4. That's -81 over 4 plus 1. That's -77. Oh, but it's all the 3/2 power. I haven't done that yet. -77 over 4, I believe. Because that's 4 over 4 subtracted by 81 over 4. So that would be -77, yeah. But this is all still to the 3/2 power. So we could resolve that without a calculator. That's probably a good skill to know. If we want to do a 3/2 power, I'm going to change this. Well, actually, here with the sign. Let's check out what happens with the sign. I could make this -77 over 4 squared over. Oh, we can't do the square root of a negative. Okay, let me pause. Think of another way. Sorry, so I caught myself working on the next part. I actually dropped a negative sign up here, right? Because f of x is negative x to the 3rd over 6. So that should be negative. And so when we make our substitution, we have du is positive x to the 3rd. This is negative x to the 3rd, so we could factor out a negative sign here. Okay, so I factored out this pi, factored out this 3. This is now du, and then this is our u. So the whole thing becomes an integral of the square root of u. Now the limits of integration have changed. This -3 was referencing x. We need to have it referencing u. So if you plug in -3 in for u, for x, sorry. If you plug in -3 for x, 3, 4, that's 81 over, positive 81 over 4, plus 4 over 4 makes 85 over 4. If you plug in 0 in for x, you get out 1 for u. So just watch out for that when you make u substitution. Got to change the limits of integration. And so now the antiderivative would be 2/3 u to the 3/2. And that's because when we find an antiderivative, the power goes up, but we still need it to be the same thing if we were to take a derivative. So 3/2 times 2/3 would bring us back to where we started. And the limits of integration are 85 over 4 to 1. So if I plug in the upper limit of integration, if I plug in 1, I get out 2/3. I need to subtract that by what happens when I plug in 85. So I can show you, I think this is a useful skill, especially since we don't know where you're going to go next for your math classes. If you aren't able to use a calculator, if you need to evaluate 85 to the 3/2, you can rewrite it with algebra in terms of powers that are easily understood. Oops, that's a 3. Miscopied that. So this is the same thing as 85 over 4 to the 2nd power divided by the square root of 85 over 4. Let me just see if Newton wants the exact answer or not, because that's going to matter next, whether we simplify this to a decimal. But look, the reason why this is the same is because treat this like an x. If you have x squared divide by x to the 1/2 power, in other words, the square root. 2 minus 1/2 gives us 3/2, right? So this is equivalent to what's up there. Let me see if Newton wants the exact answer, though. Yeah, it's going to be a bit ugly because Newton does want the exact answer, so we'll keep that there. This is negative pi over 3. This is still 2/3. Not going to simplify that yet. So minus 2/3 times all this stuff. This is going to be 85 over 4 squared. So 85 squared is 7,225. And then we know 4 squared is 16. And that was being divided by this, so we can multiply by the reciprocal, right? This is square root of 85 here. Square root of 85 over 4, all inside the square root. That's the same thing as square root of 85 over the square root of 4. So if I'm dividing by this fraction, I'm going to flip and multiply. Man, you know what the hardest part of this question isn't surface area. It's getting through all this rewriting. So here, let's see where we are at. Still trying to simplify this. I bet if you type this in, Newton would accept it. But we should know how to simplify it further. Okay, so I'm going to multiply straight across the top, straight across the denominator. Yeah, the calculus is done. Now it's just boring stuff. 2 times 7,225 times 2 in the numerator, so 28,900. Denominator 3 times 16, that's 48. Then we got square root of 85. Okay, but in math we don't like a square root in the denominator, so we can multiply the top and the bottom by a square root of 85. This is 48 times 85 now, because square root of 85 times square root of 85 gives us 85 like we wanted. So we got 4,800 in the denominator. Sorry, 4,080 I should say. And then we can probably simplify that fraction. I don't know if it would mark you wrong for not simplifying. I hope not, because this is not the calculus part. Try dividing the top and bottom by 2, maybe 4. Yeah, that's divisible by 4. That's divisible by 4. I think that's the biggest we can get. So 7,225 square root of 85 over 1020. Now we can divide the top and the bottom by 5. You just use an online fraction simplifier at this point. Okay, so I could, I don't want to keep going, but I will. I'm not going to abandon you now. 7,225 divided by 5, that's 1,445. What I would do with such big numbers is I'd try to use its prime factors, so I could find the greatest common multiple, the greatest common factor, I should say. But not everyone does that in school. Is that it? Man, I hope so. Let me see. I think I have the correct answer here. No, I don't anymore. I don't know. I think we could simplify this further. I guess it's possible. I shouldn't say I think, because I have no idea. Here. Fractions. Let's see what the online calculator says. 1,445, 204. It says 85 over 12. So we could simplify further. 85 over 12. So that should be our correct answer.